Hello everyone. I've been using ESP01 as a Wi-Fi shield for my project lately. And last week I have an idea of replacing this rusty doorbell with a pair of ESP01 running ESP NOW protocol. ESP NOW is a communication protocol developed by Expressys. It utilizes 2.4G Wi-Fi channels, but instead of connecting to a Wi-Fi router and a DHCP server, it allows peer-to-peer communication between the two ESP modules without going through the router. ESP now can send a payload up to 250 bytes, and depends on the configurations, up to 20 peers can be connected together. While working on the doorbell project, I'm thinking why not do a range test on ESP01 with the ESP NOW protocols. Now on the internet, there are several guys done that before, and CN Low actually tests a pair of ESP12F and achieve a range of more than 1 kilometers result. And this guy did a similar test with a pair of ESP32 with external antenna and claim of 480 feet range. But so far nobody done a range test with this tiny little ESP01 module to see how far this module can go. The setup is simple. One ESP01 is used as a ESP NOW receiver sitting on my balcony. The STM32 board that you see on the picture is actually only used as a power source to provide the power to the ESP01 module. Another ESP01 acts as a ESP NOW controller or transmitter. It's connected directly to my computer through a USB TTL adapters. This allows me to monitor the transmission status on my computer directly. In front of my apartment, there is this empty car park rooftop that is a good test environment. So I done a test at this location, and the distance is about 69 meters, and the result is very good. After done the first test, I noticed that there is actually a platform that 2 levels below the platform that I was doing the testing, and I actually didn't know this platform exists because it's from my apartment. I can't really see this platform, so I did a test there. There's slightly blocking because I cannot see my apartment's balcony, and I also got pretty good results at the distance of 103 meters. But in this location, because it's actually a little bit blocking, so if I move to the right side by 1 meter, the reception will change, actually with about 10-20% failures. This is as far as I can go from my apartment with open space. I need a longer open space to do further tests. Here is the first place I'm thinking about testing it. From here to the way, all the way to the bridge there, it's about 500-600 meters. And here's a small branch of tree. I can mount the ESP01 to it, and I will ride to the other side to see how the result it is. Here is the ESP01 receiver's setup, and I will set up the transmitter to see the transmission before I start to riding to the other side. Okay, the ESP01 transmitter is up running, and you can see it take very short round trips, around below 500 microseconds usually, to transmit and receive the acknowledge back. And so far it's 100% successful. And I will start driving to the other side to see what the result is going to be. Okay, let's go to the other side. Okay, here's the bridge that I previously talked about. I'm not exactly at the bridge yet. It's about 50 meters away, maybe. And on the other side, you see on the end of the curve there, over the river, over the water, that will be our the transmitter. Okay, so now it shows that it's most of the time it's failed, but occasionally you get success return. So probably this is not reliable result. I think it's only about 10% or 20% success rate at this distance. So I'm going to drive back and step by step, maybe every 50 meters away, to see where I can get about 100% or maybe 80% success rate. Okay, I move about 50 meters away from the bridge, and so that's about 50 meters closer to the receiver point. And so from here, there's no blocking, not at all, except the water. And I don't know whether water will affect the propagation of the radio wave or not. We'll see. So from here is about, the way I see it, it's about maybe 60, 70 success rate. And it definitely improved a little bit. And maybe I should move away from the water, see any impact caused by the water. So this time I'm about same distance as the previous test. And the previous test I was there, just like the bike location, the man walking there. And but now I'm moving away from the water and move on to the road and next to the building. I'll see whether the signal get any difference or not. Okay, the result here actually get even worse. It's get 100% failure compared with at by the water. So I guess all the tree and branch and the building does impact the result. So I have to move closer to the receiving point to see whether I can get a better result. I'm here like probably a football field away from the testing point, and I'm going to test this here and also move into the road, which has a lot of tree branch around the area. So as you can see, there's a lot of tree here blocking the testing point a little bit. At this point, I still see about 100% failure. Interesting. As soon as I move away from the bike lane that is blocking by all the tree to the water side, I got 100% success rate. To be honest, after seeing all the YouTube videos, I was expecting further distance. But when I think about this is achieved by those tiny ESP01 modules that cost less than $2 each. I'm happy with the result. On my final video editing, I realized there's a big gap between 250 and 420 meters. At the 420 meter, I got 60 to 70% success rate at the open space. While I got 250 meters with 100% success rate. What I should do actually is to move backwards toward the 400-meter directions and see where the ultimate distance is going to be, where the package start to fail. While by no means this is a comprehensive test, maybe next time I will do better. I hope you enjoy this video. Bye.